Okay, so we're going to start on this first page, and it says to use the definition for derivatives. What do they mean? The limit stuff. So we've got the derivative equals a limit problem, and that's important for you to understand, and you're going to need to write it like that. So the derivative equals a limit problem. So we have the limit as h approaches 0, and everywhere I see an x, I put an x plus h. And then we subtract the actual function. Now, what have I forgotten to do? Parentheses. It does matter, and that kicked your tails on that last quiz, so watch that. Or 2 quizzes ago, I should say. And so from here on out, like, this is kind of the process. Now we just need to use some algebra to kind of get us to a better place. So with the limit as h approaches 0 for x squared plus 2xh plus h squared plus 7x plus 7h minus 2 minus x squared minus 7x plus 2. Fun. So far your paper should match mine. X squared minus x squared, 7x minus 7x, negative 2, positive 2. I'm left with 2xh plus h squared plus 7h over h. What do we do? Take out an h. Divide by h, divide by h, divide by an h, divide by h. We are still in the middle of a limit problem. Thanks, Spence. Did you find your person? Did you figure out who it went to? Yeah. Good. Wait, is this it? 7, thank you. I see it. Now what do we do? Now you can plug your 0 in for h. And that is what makes it no longer a limit problem. The derivative is what we get when we plug the 0 into h. We're approaching 2x plus 7. And that is a fancy formula to find the slope for any tangent line on that function. Have we finished the question? No, it wants you to find the slope at x equals 0. When x is 0, what's the slope of the tangent line?
Plus 7.
It is 7, and here's how we get it. We take the derivative, we plug in 0 for x, and we get 7. How many of you guys already had 7 on your paper and you did it this way?
Oh.
Ah, yes, you got to read the directions. Got to use the definition for derivative. This little guy here, we're going to go through the exact same process, and I'm actually going to work this one out as well because some of you guys really stink at common denominators. So, no, I'm not wrong. So the derivative of g is a limit problem. The limit as h approaches 0. Everywhere I see an x, I put an x plus h. Okay, I'm going to rewrite this thing with common denominators. What is my denominator going to be? Exactly, and that's where it's confusing. Several of you guys just are like, okay, I've got an x, so I just need an h. That's x plus h. Be careful, these are 2 separate terms. So that denominator is going to be x times x plus h. You have to have both pieces. The numerator was a negative 2. We had x plus h, we need the x. So we have negative 2x. Minus negative is a plus. 2 times, I need it to be multiplied by x plus h. I'm going to go ahead and distribute. Does that freak you out? Is that okay? Are you alright? So I've got a negative 2x and a positive 2x. So I have a 2h on the top. Also on the bottom down here, I've got an h over 1. When dividing fractions, don't ask why. Flip the second one over and multiply. So now that guy's gone. What can you do with these guys right here? Yeah, you can take out an h. We can divide by h, divide by h. So now what we're left with is the limit as h approaches 0. I've got a positive 2 on top. And on the bottom, I've got an x times x plus h. Is that it? Yep, I think that's what I got. Now what? Yeah, now you can plug in your 0 because it does not make the bottom undefined. Now, whoops, that's a g, sorry. Now we have the derivative of g of x is 2 over, if h is 0, that's x squared. They want to know what the slope is if x is -2. So we plug in -2 everywhere we see an x. We get 2 over 4, which is a half. Everybody okay on that one? Okay, the next one gets a little longer. And because we're not using the power rule, it doesn't do you any good to rewrite that thing. So let's just leave it as it is. And the derivative of h of x is the limit as h approaches 0 for everywhere I see an x, I put in x plus h, minus the actual function all over h. It's not real fun, but we should probably get some common denominators here. It's really not that bad. So that your denominators are radical x times radical x plus h. The numerators, it was a 1, so it's now radical x, minus it was a 1, it's now radical x plus h. Hello, thank you. When dividing fractions, don't ask why. Flip the second one over and multiply. But has that h really done anything for us? It really hasn't. We're just going to have to rewrite the problem. So we have equals the limit as h approaches 0. On the top, I have radical x minus radical x plus h all over h times the square root of x times the square root of x plus h. I feel like this is just getting worse. What do we do? Cry. If you plug in 0, it's going to make it undefined. There's an h right there. There we go. Multiply by the conjugate. So you take the middle sign. Conjugate is a binomial where the middle sign is the opposite. And the reason we do that is because when you FOIL on the top, thank you. On the top, when you FOIL it, the first terms, square root of x times square root of x is x. The outer and inner terms are going to cancel. That's the whole point of the conjugate. The last terms, we get x plus h. The root just pops off. And we're subtracting. What'd I forget? Parentheses, because you're subtracting the whole thing. Good job. Over, don't try to multiply this out. Just rewrite the mess. It's going to get pretty here in a minute. On the top, I have x minus x. So now I have a negative h. On the bottom, I want to get rid of this h. That would really help me out with this whole thing. So divide by h. If I divide by an h, I have a negative, you see it? -1 on top. Please don't forget your negative tomorrow. So, can I plug in zeros now? Yeah, now it's perfectly fine. So the derivative of h of x is -1 over. If I make that a 0, I'm going to have the square root of x times the square root of x, which is x. And then over here, if I make that h a 0, I'm going to have the square root of x plus the square root of x, which is 2 square roots of x. If I write 2 radical x right there, do you see how it would be better if I put the 2 here and the radical x here? Mathematically, it's just sort of more grammatically correct, if you will, to write it in that order. And they want to know the value of x is 4. Out of habit, I keep putting an f. Sorry. The derivative at 4 is -1 over 2 times 4 times the square root of 4, which is -1/16. Is that what you guys had? Everybody okay? Questions on any of those first three?
What was answer B?
B is a half. Letter D is kind of just more the same. You get -2 for your answer. -2. And I can come back and pick that one up and work it if you want me to later. Next page. Find all points at which the graph of that function has horizontal tangent lines. Horizontal, what's that slope? 0. Problem is on a recent quiz, you guys were given a function and you're supposed to find where the slope was maybe a 1 or a -1. And some of you guys still set it equal to 0. You only set it equal to 0 if they tell you to. Horizontal tangent lines, that's where the slope is 0. If they give you another number, plug in the other number. Have they told us to use the derivative definition? No, so please let's use the power rule. We wind up with 12x cubed plus 9x squared. Does anybody not know where that came from? Thank you. Is everybody okay? Okay, let's set it equal to 0. Factoring would probably help us out. So we can factor out 3x squared, and that gives us 4x plus 3. Now what? Yeah, set them both equal to 0. So we have 3x squared equals 0, so x would be 0. And we have 4x plus 3 equal to 0, so x would be -3/4. So at 2 places, we're going to have a horizontal tangent line where x is 0 and where x is -3/4. How do I get the y value? Do I plug it in the original or the derivative? Does matter. Into the original. I'm going to go back into the original because we're looking for the point on this graph that has a slope of 0. So that's why we plug it back in that one. If you put a 0 in for x, you get -2. I would use my calculator to type in -3/4, and you get -2.3-ish. Yes, sir. Ma'am.
Can we use a calculator tomorrow?
No, so I would not give you a problem that required that.
Yeah, also when like is later and ask for like the second derivative and stuff like that.
They should be numbers that are really easy to come up with.
Okay.
Yeah. Good question. All right, moving on. The derivative of this little guy here. This isn't an issue for most of you except for those pesky trig functions. Make sure you have those memorized. Power rule. This is going to be 6x to the 5th plus 6x. And what is the derivative of tangent? Secant squared x. Know it, know it, know it for tomorrow. Questions? Make sure you know cotangent of x. Make sure you know cosecant of x. Make sure you know secant of x. Next one. It says use the product rule to find the derivative of the following. Now because they've told us to use product rule, we don't have a choice. If you had a choice, maybe you might do it a little differently. Derivative. This is where we take the first function times the derivative of the second function plus the second function times the derivative of the first. So first function is x squared minus 5x plus 2 times the derivative of the second, which is 9x squared minus 2x. Plus the second function, so 3x cubed minus x squared plus 5 times the derivative of the first, which is 2x minus 5. Any questions before I got that? Okay, so now we multiply it out. I'm going to take all 3 of these guys times 9x squared, and I get 9x to the 4th minus 45x cubed plus 18x squared. All right, start watching my math because this is where I get crazy. I did this morning. I don't know what in the world is wrong with me. -2x times all those guys. And we have -2x cubed plus 10x squared minus 4x. Am I good so far? Great. Next one, I'm going to take 2x times all these guys. And I have plus 6x to the fourth minus 2x cubed plus 10x negative 5 times all these guys. Yes, this is really long. Thank you. Negative 15x cubed plus 5x squared minus 25. How did I do?
We showed the whole thing.
This is, I think, as far as I can go. It won't zoom out anymore. Sorry. All right, let's start putting stuff together. I'm going to use a different color pen here. All right, I've got 9x to the fourth and 6x to the fourth, so that's 15x to the fourth. I've got negative 45x cubed, and negative 2x cubed is negative 47x cubed. Minus 2 more is negative 49x cubed. Minus 15 more is negative 64x cubed. Is that right? Thank you. Now I have 18x squared, and 10x squared is 28x squared. And 5 more. I don't even know what I just said. What did I say? 28 plus 5? What is it? Wait, where are we?
33.
Thank you. 33x squared. Thank you for turning that in, by the way. Hey, Jake, was there anybody left in that room, or were you the last one? You were it? Okay. Now we have, where are we? Negative 4x, and 10x is 6x. And then negative 25. How many of you guys already had that on your paper? Sweet. Good job. Next one. They tell us we have to use the product rule. Can we do anything before we start that mess? Oh, make the yeah, let's rewrite this to make it a little bit easier. This is actually 3 times x to the negative 1 plus x times 3 times x to the negative 1 minus x. Now, if you'll notice what's interesting about this is these are conjugates, right?
Yes.
And we're not allowed to multiply them together now. We have to use the product rule, but somewhere a bunch of stuff is going to cancel. You kind of know that's going to happen. Here we go, derivative. The first function times the derivative of the second function. So negative 3x to the what? Negative 2. On your quizzes, some of you weren't sure how to subtract 1 from that. Negative 1 minus 1 is negative 2. I think you actually know it if I isolate it like that, but I think you got in a hurry and you went the other way. You started adding exponents. I don't know what happened. What's the derivative of negative x?
1. Negative 1.
Negative 1. Good. Do I add or subtract now?
And
Plus the second function times the derivative of the first function. And now we multiply everything together. The first terms, and I hope you're paying attention, most of you will get the fact that we have a negative 9 here. Here's where you get messed up. X to the negative 1 times x to the negative 2. First of all, are you even allowed to multiply those together?
yes.
Yes. The bases match and you're multiplying. So what do you do with the exponents?
And
Add them. So it's x to the negative 3. The outer terms get you negative 3x to the negative 1. The inner terms get us negative 3 times x to the what? Negative 1, I heard it. And then the last terms get us minus x. Now let's FOIL the second part. The first terms get us negative 9x to the negative 3. Outer terms get us positive 3x to the negative 1. The inner terms get us positive 3x to the negative 1. Last terms get us minus x. Let's put together what we can so we can be done with this thing. Okay, let's see here. I've got negative 9x to the negative 3, negative 9x to the negative 3. So how many do I have? 18? Negative 18? So I have negative 18x to the third, like that. Why did I do that?
so you don't have negative exponents.
So you don't have negative exponents. On this one, we are not allowed to have negative exponents because they didn't give you any to start with. Alrighty? Now we've got, if you'll notice, this, and this all cancel. Kind of knew that was coming. Negative x and negative x is negative 2x. Everybody okay? All right. Moving on. Next one, product rule. First function times the derivative of the second. What's the derivative of cotangent x?
Minus cosecant squared of x.
Good. Somebody's been studying. Negative cosecant squared x. And the derivative of 3 is?
0.
0. Good job. Plus the second function times the derivative of the first function. What's the derivative of sine? Cosine. Derivative of x? Good. And now we multiply them out. So we multiply everybody by negative cosecant squared x. Now, if I take sine of x times negative cosecant squared x, watch this on the side here in the margin. Sine over 1 times negative cosecant, isn't that 1 over sine squared? Isn't this that? So what happens here? You can take out a sine, can't you? Take out one of the sines, take out one of the sines. Now I have negative 1 over sine. What is that? Good. Negative cosecant x. Good job. And now the second guy times this is going to be negative x cosecant squared x. Foil the last ones. Plus, now if I multiply my first terms, cotangent times cosine, does anything happen there? If you aren't sure, you can write it. Cosine is, or cotangent is cosine over sine times cosine over 1. Did anything happen? Nothing cancels, nothing goes away, it just gets crazy. So we're just going to leave it as cosine x cotangent x. The outside terms get us cotangent x. The inner terms are plus 3 cosine x. And the last terms are plus 3. Does anything go together? Nothing goes together, so
That's it.
yeah. Sorry, Alex Byrne. All right, so nothing goes together there, and it's just kind of a big mess. But that's the answer. Does anybody have any questions so far? Is everybody okay? Dalton, you good? Okay. Number 5, find the equation of the tangent line and the normal line.
Have we done that before?
We've never used that word in here before. Normal is a fancy word for perpendicular. If you have a slope, how do you get a perpendicular one? The negative reciprocal. All right, so here we have, let's see, they give us a point, they give us a function. Let's find the derivative. And we don't have to use our limit definition, hooray, so we can use power rule, and we get 3x squared minus 9. They want to know what happens at 3, 5. What do I do? Do I set it equal to 3? Plug 3 in for x. Don't set it equal to 3. Some of y'all did that. Take 3, plug it in for x. So the derivative at 3 is 18. All right, did I just find my x, my y, or what? I found the slope at that point. So to write our equations, that we say y minus the y they give us equals the slope we found times x minus the x they give us. That's the tangent line. They want the normal line. The point does not change. Those pieces still match. What does change is the slope. What is my new slope? Negative 1/18. So Alex, all you have to do is change the sign, flip it upside down. Alrighty? Possibly. How's that for a definitive answer? Alex, you good?
Oh.
Okay. Alrighty, moving on. Same kind of question. I don't like that the letters got switched here. This should be a T. Let me just give you the answer because it's the same process. Unless, does anybody want to see me work that out? Are you guys okay?
Well, I got 2
It was a little tricky. Do you want me to work this one out? You just plug it back in the original. Yeah, once you work it out and you get your slope, you have an x right here, and you have a slope. Plug in your x to get the y, or your t to get the y, I should say. So if this is our equation, we know the answer to the other one. What's the slope?
1/7.
Positive 1/7. Good job. Number 5 is a little different because we've got this radical x thing going on, which, speaking of, the pause button here. I need you guys to think about this. If this is your equation, and I'm asking you to find the derivative, what would you do first? Okay, so we'd rewrite it as an exponent. Remember, it's inside over outside. Now what? And that's where some of you guys went wrong, because you didn't know how to multiply fractions. You have a -2 times a fourth. If you have to, write it out. -2 times 1/4 is -2 over 4, so it's -1/2. You with me so far? Yes? Yes, and I agree. Because most of your most of the calculus process for you is fine. You stink at the algebra. So fix it. So we have -1/2 here. Here's the second place you went wrong. How are you supposed to get your new exponent? Subtract 1. Some of you had no idea how to subtract 1. I got crazy answers. If you have 1/4 minus 1, or can I call that 4/4? You get -3/4, yes? So I have -3/4. So if you made it that far, there's a third obstacle that really caught a bunch of you. You knew you couldn't have a negative exponent. You knew I wasn't going to be okay with that, especially because they didn't even give you exponents to begin with. They gave you radicals. I want radicals back. Here's the question. X to the positive 3/4, does it go next to the 2 or like all the way under the whole fraction? I'm asking because a bunch of you didn't know. Think about what this means. If you have -1/2, doesn't this mean times this guy right here? So we're multiplying by 1 over x to the 3/4, right? Now is it kind of clear what's supposed to happen? If you multiply across the top and then across the bottom, you get -1 over 2 times x to the 3/4. So it squishes up next to the 2. Are we finished? No! I give you radicals, you give back radicals. It's the polite thing to do. So we have -1 over 2 times what? How do I do that? Inside over outside. So x cubed is on the inside of a 4th root. That's the answer. This is all being recorded. I will upload this, and that's important because that was not pretty on your quiz. All right, so all of that said, let's rewrite this guy so that we have 6 times x to the what? Thank you. All right, derivative?
3x.
Good. 3x to the -1/2. Emily's on a roll. -1. Question, Alex, you said? No? Okay. Okay. Now we need to find our derivative at the x value they give us, which is 36. Whoops, I don't know why I put 66, sorry. Okay, this really means 3 times. Isn't that 1 over 36 to the 1/2? So 3 over, what's 36 to the 1/2? So it's really a 1/2 minus 1, which is -1/2. So here's our tangent line. Y minus the y they give us equals the slope we found times x minus the x they give us. What's our new slope? +2. Opposite reciprocal. Differentiate this guy right here. Alrighty. We're gonna have to use what? Quotient rule. Booker T minus Taco Bueno over B squared. Make sure you know that those are derivatives there on the end. Somebody last week didn't know that. Was it? I wouldn't have even remembered. Maybe Patrick said it. Well, you weren't the only one, Alex, I'm sure. Bottom times derivative of the top. So we have x to the 7th minus 2 times the derivative of the top, which is 2x minus 3. Any questions with where I got that so far? Be careful and make sure you know this formula. Several of you put a plus sign between those. Be careful. The top is x squared minus 3x plus 2 times the derivative of the bottom, which is 7x to the 6th. All over, here's another place you messed up. A lot of you guys forgot to square that on the bottom. You've got to know that formula, it's squared. All right, algebra. We're going to FOIL this piece right here. So the first terms, we get 2x to the 8th. The outer terms, we get negative 3x to the 7th. Inner terms are negative 4x, and the last terms are plus 6. Over here on the right-hand side, I'm going to distribute the negative and the 7x to the 6th at the same time. So that I have negative 7x to the what? 8. Good job for adding the exponents. Then I'm going to have positive 21x to the 7th. Then I'm going to have negative 14x to the 6th. Hope somebody's double checking me and making sure I'm doing this right. Okay. On the bottom, why didn't I FOIL that one out?
It's too much work.
Yeah, it's not going to help you. It's not going to make it any more simple. In fact, it's going to look like less pretty. So just leave it. Let's see if we can put some stuff together now. On the bottom, I've got 2x to the 8th and negative 7x to the 8th. So that's negative 5x to the 8th. Then I've got negative 3x to the 7th and 21x to the 7th. So that's 18x to the 7th. Then I've got negative 14x to the 6th. Got negative 4x and a positive 6. All over x to the 7th minus 2 squared. Questions? Okay. On the last one, we need to rewrite that so that it's 3s to the negative 3rd minus 9s to the negative 1. And then it's just simple power rule. So we wind up with negative 9s to the what? Thank you for knowing that, because again, some of y'all didn't. Negative 9s to the negative 4th minus plus, just kidding, 9s to the negative 2. Can I leave it like that? Nope, they did not give you negative exponents, so you cannot give it back. So we rewrite it as negative 9 over s to the 4th plus 9 over s squared. Now you're good. Everybody okay? Say again? This one? Sure. No problem. Yes, sir? That's a great question. You could. I would take it if you just left it like this. But yeah, you probably should. They didn't on this worksheet, but yeah, you probably should. Good question. He asked about common denominator. You guys good? Carson, you good? On 6b. Do you know where this came from? Did you see how there's s cubed on the bottom?
Yes.
It's the same thing as s to the negative 3 on the top. So I rewrote both those, and then I just did the power rule.
Okay.
Like, is that okay? And Carson, I'll let you look at this again when we finish up if you want.
Yes, ma'am.
Yes, sir.
Could you also apply that 9 by s squared
Oh, like to get common denominators? Yes, you could, totally. Absolutely. All right, next page. Second derivative. They don't specify what rule we have to use. So what might make this process a little faster? Yeah, let's FOIL the top. So this is going to give us x cubed. Outer terms get us negative 9x squared. Inner terms are positive 3x squared, and the last terms are negative 27x. Put them together so that we have x cubed minus 6x squared minus 27x over x cubed. What can you do? Yeah, we can take out an x, can't we? So now I have x squared minus 6x minus 27 over x squared. Now, most of you from here would probably do the quotient rule. And you can, and it will get you there. Do I have a copy of what I did this morning? This morning I did it for first hour. That's what I wanted to do. And it took a long time, and there's a lot of chances for error that way. I have sort of a faster way if you'd like to see it. Let me ask you. If I have 7/20ths, is this the same thing as 1/20th plus 4/20ths plus 2/20ths? Yeah, I could interchange those and it'd be the same thing mathematically. So, if this is what I have here, couldn't I rewrite that as x squared over x squared minus 6x over x squared minus 27 over x squared? Isn't that the same thing? So long as they all have the same denominator, it's perfectly legal. It's the same thing that we just did here. You took what you had and you split it up, and as long as they all have the same denominator, that is perfectly legal. Because think about what would happen if you put all these together. Wouldn't it be what we just came from? Yeah. So let's kind of fix this. X squared over x squared is 1. This guy reduces to 6 over x, and this guy stays the way he is. I'm going to rewrite it another time. I'm going to say 1 minus 6 times x to the negative 1 minus 27 times x to the negative 2. So I made all of my exponents on the bottom negatives. And now it should be fairly simple to do derivatives because it's just power rule. So the first derivative is going to be 0 plus 6 x to the negative 2 plus 54 times x to the negative third, right? Second derivative, negative 2 times 6 is negative 12 times x to the, that's going to be a negative 3. Negative 3 times 54 is negative 162 x to the negative fourth. Can I leave those negative exponents there?
Absolutely.
Not this time. So we just rewrite it up here as the second derivative is negative 12 over x cubed minus 162 over x to the fourth. That is much faster, much less messy than the whole quotient rule mess, trust me. Yes, ma'am, Marina? Let's scooch up that a little bit. Like right there? Okay. Dalton, did you have a question? Or Alex? Somebody over here did.
I just showed all the answer.
Okay. Hang on. Marina's trying to get the left side. Can only, like, scooch out so far. Did you get it, Alex?
Yes.
Medina, you good? Not so much yet? Okay. Letter B, you're just finding a second derivative. That means find the derivative and then find the derivative of the derivative. For letter B, you should get 10 plus 60 over x to the fifth.
Gave you negative exponents together.
Yes, because there's a negative exponent, you could give back a negative exponent. That would be fine. Letter C, second derivative is 22t. And And if this piece right here threw you off, if it helps you, rewrite that as 11/3 t cubed. That probably helped most of you. That's what that means. It's the same thing. Letter D. Some of you maybe didn't see that you could rewrite these. Sorry. You can rewrite that as 1/7 x to the negative 2 and 1/5 x to the negative 1. Those mean the same thing. So that on letter D, your second derivative, you should be able to get, let's see, 6/7 x to the 4th plus 2/5 x to the 3rd. The last one, you need to use product rule, but there's a problem with this guy on the left. I would break that apart and rewrite that. It will make your life so much easier. So I would rewrite this guy as one over 3x plus 3x over 3x. And then you can fix it again so that you have 1/3 x to the negative 1 plus 1 times 3 minus x. And then apply your product rule. Or distribute and then do your product, and then do your power rule, which is probably faster actually. You guys ready for the answer on that one? It's 2/x cubed. 2/x cubed. Are there any questions so far? The last three go fast. Okay. They're asking for the derivative of uv when x is 1. They're multiplying two functions together, so what rule is that? Yeah, it's the product rule. So I need u times the derivative of v plus v times the derivative of u, where x is 1, and they gave us all of those values right there. So u at 1, they said was 2. The derivative of v at 1, they said was negative 4. V at 1, they said was 7. And the derivative of u at 1 is negative 6. Put all that together, you get negative 50. Questions on that one? Okay, going down. Same thing, but we've got the quotient rule. So you're going to do that one the same way, and you get negative 22 over 49. How did I get the negative? I don't know. Let's see here. Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. So v is 7 times negative 6 minus 5 times negative 4 over 7 squared. That's 49 in the bottom. This is negative 42 plus 20. Let's make it negative. Maybe you did it backwards. All right, the last one shouldn't be tricky, but I think it did throw a few kids off this morning. They came in for help. You've got 2 times a function here. According to your rules for derivatives, you would just take 2 times the derivative of u minus 4 times the derivative of v. You are allowed to do that. That's what that is. That's what you've been doing probably without realizing it. So we have 2 times 2 minus 4 times negative 5. And we wind up with 24. Okay, you've got me for a few more minutes. What do you want me to go back and do some of the ones I didn't do? Do you have specific questions? Do you want me to talk about graphs? Sure. So D on the first page. we have to use the limit definition, so we say the derivative of f of x is the limit as h approaches 0. Everywhere I see an x, I put in x plus h. Minus the original function all over h. Can't put in a 0 because it makes the bottom undefined. So we have some work to do. We need a common denominator on the top. This is one of those ones where some of you guys are like, oh, I already have the x and the 2, I just need the h. Doesn't work that way. These are two separate terms. So we have x plus h plus 2 times x plus 2. That is the denominator. For the numerator, the bottom I multiplied by x plus 2, so the top, if I multiply by x plus 2, I'm going to go ahead and distribute. For the right-hand side, I had x plus 2, I need x plus h plus 2. Let me go ahead and distribute that too. It's in parentheses because we're subtracting the whole thing. So I've got, let's see here, 8x minus 8x, those went away, and 16 minus 16. I'm left here with negative 8h. And I'm dividing that fraction by h over 1. When dividing fractions, don't ask why. Flip the second one over and multiply. So now when I look diagonally, I can cancel out an h. So I divide by h, divide by h. I now have the limit as h approaches 0 for negative 8 over x plus h plus 2 times x plus 2. Now what do? Now you're allowed to plug in 0, so that I actually do have the derivative now. After you plug in 0, that is now considered the derivative. So I have negative 8 over x plus 2, the quantity squared. They want to know the value of the slope at 0 if x is 0. So the derivative at 0 is negative 8 over 0 plus 2 is 2. So negative 8 over 4 is negative 2. Good question, Sarah. You guys want to see graphs real fast? Are you guys good?
Yes.
So it looks like this. I think what is smart, if it's asking for the derivative, I think a smart thing to do is just look everywhere you're going to have a tangent, horizontal, or horizontal tangent line, which is going to happen here, and here, and here. Remember, if I make a t-chart of this graph, the slope over here is going to become the y value for the derivative graph. So at negative 2, the slope is 0. At 0, the slope is 0. And at probably 3, it's at 0. So these are now ordered pairs on your new graph. I can't zoom out any more than that, can I? Crap. That's okay. 1, 2, 1, 2, 3. So I have that point, and that point have to be on the graph. Yes, ma'am? X-axis, yes. Correct. Alrighty, so then we say, okay, left of negative 2. Are these slopes positive or negative, those tangent ones? Negative, right? So I know on the left-hand side, these are all going to be negative numbers, which means if these are my new y values, they're below the x-axis. All right, let's look between negative 2 and 0. These tangent lines, what are the slopes? are all positives. So between there, I need positive numbers for my y value, so it's above the x-axis. It's up here somewhere. Until we get to 0, 0, and then what happens to our slopes? They're all negatives until we get to 3. So all of these are negative values. All those y's are now below the x-axis. Sorry. And then, of course, these last little bits, all of those tangents are positive, so it's now above the x-axis. So there's your derivative. Alrighty, let me turn this off.
Do we turn the curve